You're watching my channel Spark Virtual Academy. Do not forget to subscribe and like my channel to get the latest updates about the new topics. And in today's lecture, we are going to learn about the physics, and we are going to start the chapter number 6. In chapter number 6, the first thing that we are going to learn today is about the parallel forces. Okay, as the name suggests, parallel means the forces which never meet each other. Okay, so let's suppose this is a body, any body. If the forces which are acting on this body are in this direction, or even if they are in this direction, so such type of the forces are known as the parallel forces. It means if the forces which are acting in parallel direction on a body, then such forces are known as the parallel forces. For example, if we are pushing a car, then we are pushing it from one side, and if my partner joins me just beside me, then we both will push in the same direction, so that is the parallel direction. Or even if I am pushing it from one side and the boy, he is pushing it from the other side, so both the sides are opposite to each other, like this one. Okay, I am pushing the car from this side and he's pushing the car from this side, so again this is the parallel forces. Okay, these are the parallel forces. But if the third boy, he joins and he starts to push this car from that side, now that is not the parallel force, because it is intersecting these parallel forces. Okay, so the direction of those forces should not intersect each other, and such type of the forces are known as the parallel forces. We have two types of the parallel forces. One are the like parallel forces, and the other ones are the unlike parallel forces. Since the name suggests, by their name, the like parallel forces are those forces which act in same direction. However, unlike parallel forces are those parallel forces which act in opposite direction. Okay, it means if you just take this example, if four people, they are pushing that car from this direction, so they all are parallel to each other and they are like parallel to each other. Okay, and these are the 1, 2 and 3, these are also the parallel forces, and they are also parallel to like to each other because the direction is same. But if we compare these both together, now these four forces, they are opposite to these three, so we can say that they both are unlike parallel forces because their direction is opposite. Okay, so there's just small difference between these two. Okay, if me and my friend, we both are pushing the car from one side, from the back side of the car, then they are the like parallel forces. But if I am pushing the car from back side and my friend, he is pushing the car from the front, so that will be the unlike parallel forces. Now let's describe the resultant of these two forces. Okay, so here we are just drawing the resultant of like parallel forces. Okay, so let's suppose again the same figure here. If we are just supposing this is a simple body, or we can say that this is a car or anything, you can just suppose it. Let's suppose one force which is acting in this direction on this body. Now this is F1, which is acting in the upward direction, in the anti-clockwise direction. And let's suppose there is another force which is also acting in the same direction, that is the F2. So since both the forces, they are acting in the same direction, so the resultant of the like parallel forces it will be, means greater than the actual force. Okay, so we can say then the resultant of the like parallel forces is always equal to the sum of the forces. It's not necessary that only two forces are acting on a body. There can be the nth number of the forces, the numerous number of the forces acting on a body in the same direction. So then we will just combine those forces together and we will get the resultant of the like parallel forces. Remember, the resultant of the like parallel forces is always increased, or we can say it is always greater, okay? Because both the forces are acting in the same direction. I gave you an example of pushing the car with my friend. If me and my friend, we both are pushing the car from the back side, so certainly we are two forces, so the resultant force will be greater and the car will move faster. Okay, if I move the car, push the car from the back side, I will, means move it slowly. But when my friend joins me and we both are pushing the car in the same direction, certainly the resultant will be greater. Now let's talk about the unlike parallel forces. The resultant of unlike parallel forces. As I told you, like parallel forces means the forces which are acting in the same direction. However, unlike parallel forces means the forces which are acting in the opposite direction. So let's take an example. If we are just taking the example of the same car here, and let's suppose if I am pushing the car from this side, from the back side, let's say that is this direction, okay, and this is force 1, and let's suppose here another person, he is pushing the car from this side, and as you can see there, the direction of the force 1 and force 2, they both are opposite to each other, okay? So they can be some other forces as well, it's not a big deal, okay? But their directions are opposite, so they both are the unlike parallel forces, and their resultant will be equal to F1 plus, or we can say that minus F2. Now here, as we know that in physics, this minus, this negative sign always shows the directions. As you can see there, if F1 is positive, then F2 is in the negative direction. So that's why we just put it into the negative, and we will solve it. F1 plus and minus, that will be minus and F2. So the resultant of the unlike parallel forces is always equal to the subtracting those forces. It means the forces which are in the same direction are always subtracted from the forces which are in the opposite direction. So since we are subtracting, the effect of the resultant force will be smaller than the actual one, okay? It means, I just gave you an example of that car again. If I am pushing the car from the back side, and my friend, he is pushing the car from the front. Now here, the resultant will be smaller certainly, okay? If I am stronger than my friend, then I will push the car in front, but it will be slower, okay? However, if he is stronger, then he will stop the car and he will not allow it to move, okay? So we can say that the resultant of the unlike parallel forces is always decrease, or we can say the smaller, okay? So that was all about the parallel forces, like parallel forces and unlike parallel forces, and about their resultants as well. If you have any question, you can put your question into the comment box. I will try to answer your questions. Till the next lecture, Allah Hafiz, bye bye.